It's because I'm reordering some things here. Yeah, that should be fun. Okay, so this morning what we saw was the ability, excuse me, it was yesterday, in the waning hours of that day, we actually recorded, thinking that it would be a source of potent insight into burden, the number of individuals who passed away in the model. We thought it would give us insight into the burden of heart disease induced by smoking, amongst others. We found the relationship, because of multiple generations, more complicated. That was, as I emphasized this morning, a longitudinal measure at a population level. It was a cumulative count of deaths that have occurred. We're going to emulate the basic idea of capturing a longitudinal pattern. And indeed, the means of adding it, but it's going to be different because it's going to be at an individual level. We'll be keeping track of individual history information here. The importance of this is hard to overstate, actually. People's history often provides profound insights into their current situation. For example, were they exposed to traumatic events in recent decades? Were they exposed to adverse childhood events in childhood filled with physical adversity or worries? Here, we have a somewhat shorter time lens, but it's still important, the number of times someone was infected. So we're going to keep track of that. And we're going to use that information as part of our reporting from the model in this newer type. So what we're going to do is go to person. Well, we're at person here. Make sure you know where you're at. You're at person. Good. And we're going to do something that mirrors the spirit of what we did yesterday in recording a cumulative count of infections. Excuse me, a cumulative count of deaths. Do you remember what construct, what building block did we use to record the cumulative number of deaths yesterday? The cumulative number. We kept that information in a certain place, that element of state of the model in a certain place, the cumulative count of infections that occurred. How did we store that information? We used it begins with a V, ends with an E, and has an R. Begins with VAR.
Hazard rate, I think.
So there was a rate for dying. That's true.
It's a variable, yes.
It's a variable to accumulate that information. It was a count. It was an integer variable. And we'll do the same thing here. Same idea, mutatis mutandis. But here it's at an individual level. So we add it into person, right? It varies per individual. We're keeping track of it per individual. In this variable, we will call count times infected. Maybe you would say it should be count infections, but that sounds like maybe it's keeping track of whether they're currently co-infected by multiple things. This is count times infected. You could call it cumulative count of infections, and that might be better, but we'll live with this. Count times infected, if we may. And this is it a double? Is it a color? Is it a Boolean? It's a what?
Double or integer?
It's
I don't know.
An integer. It's a count. Integers are used to keep track of counts commonly. They can also be negative, but here we won't be going negative. I wish there was a thing called a natural number. It'll be initially 0. Everyone's going to start the model prior to starting the model, they're going to have the value 0. And now we're going to need to increase it when they get infected. We're going to bump it up by 1, just in the way we did in that other model, the model of tobacco use in heart disease, smoking and heart disease, in the way we did there with the count of times, the count of deaths that occurred cumulatively. So there, we needed some place to record the number of deaths that occurred. And it was in that kind of death state. You may remember that sort of thing looked like a Death Star. Sort of a circular thing with a black back center. So here, where's a natural place in the model where we know, where's a pathway or a place in the model where we could increment this when an infection occurs? Where might we put it? If we want to increment that, we want to add 1 to it, upper tally, to record that infection occurs. Where does an infection occur here? Can you point to something that would indicate the occurrence of an infection?
The flow from susceptible to infective.
Yeah. Or transition, it's a preferred term.
Yes.
But yeah, that's right. That's right. So we could put it here, and that wouldn't be bad. But I would point out there's another way of getting here that also infects someone from this status. They could be initially infected. So while that would be, by all accounts, a good place to put it, we really need to put it then in this as well. And there's an elegant place to put it where, in fact, we change the color to red, which is upon entry to the state. So yes, morally, this is something which occurs in a transition. In fact, along these 2 transitions. But just because there are 2 of them, and I don't want to duplicate this thing, I'm gonna put it upon entry to the state. That'll be the consolidated place. Anything coming into that state, even if we add some later associated with, I don't know, vertical transmission or something, we'll put it here. Okay, now Jeff has taken the lead, and that's a good way. And what Jeff is showing you, yesterday I did something like this: count times infected equals count times infected plus 1. And I kind of mumbled how you could do it, how you could undertake that in multiple ways. It's a perfectly good way to do it, but the truth is there's more succinct, in fact, more clear and less potentially distracting ways. The problem with this way, in my mind, it's perfectly good. I don't have anything bad to say, but you do have to glance, like, in understanding this. Okay, is this thing the same as this thing, or is it adding to something else and then assigning it this to be the sum of that and 1? So it's actually more elegant to say plus equals 1. And it is a command. We're saying, do it. Increment this thing. Boom. Bump it up by 1. Tally it up. So I'm going to say plus equals 1, meaning it's increased by 1. An advantage here is you don't have to look, is it something else plus 1? No. You just have to look, okay, it's being increased by 1. And I did refer to there's being another way yet, which is plus plus, but I in my view, it has a kind of nice balance between being parsable at a glance, immediately recognizable, and not being quite as bad jargon-wise plus plus. So it's a question, will the count be affected by the internal transition? The answer is no. And that's one of the things I was taking into account here. Now, this may be a time to tell you a somewhat awkward fact. Well, it's just something you might have thought you don't need to worry for, but you do want to watch out for it. The reason that it's not incremented by this transition is because this transition does not leave the state. So they're not leaving the state and coming back in. However, as we said, Sarah knows her stuff very well, and she may be aware that if you have a transition of this sort, which looks morally like the same thing. I mean, it's just, a visual difference. It's just sort of stretched outside of the thing. This actually leaves the state and comes back in. And that matters. We'll probably see this later to recalculate hazard rates of leaving the state. If you have a hazard rate that's leaving by age, varies by age in a continuous way, or by how many cigarettes someone has smoked, or how long they've spent in a former smoker state, and you want to recalculate their chance of leaving per unit time, you put in one of these, and they actually leave the state and come back in, and it recalculates that. And here you don't want to do that, because it will reset how soon they leave with this timeout transition. You don't want to do that. You wanted an internal transition, and that's what this is. An internal doesn't actually leave. It just stays in the state and undertakes this action. This actually leaves and comes back in. Both have, if this were a rate transition, both would have the general property of something going on here around this state on an ongoing basis. But this one actually would leave and come back in and would execute the entry action, whereas this internal one here does not need to. Okay. Which I find mildly disturbing. Like, I understand it, but someone could be forgiven for not noticing the difference, not thinking there's a difference. I mean, it might be nicer if you had a self-transition, wherever it is visually, have a little checkbox that says, does this actually re-enter, leave and re-enter, or alternatively just select, that it stays within the state. Well, it knows because it's coming out, and that's why I didn't bend this out to show this, because I don't want to poke the beast. I don't want to cause problems. Anyway, I didn't want to, risk that pulling it out would lead it from then on to think, and I don't think that would happen, but didn't want to take a chance. Okay, so here we are tallying up in this entry action the count of times they've been infected. Whether they come in this route or this way, we're tallying it up. Let's go try it. Remember Jeff McDonald's adage, always keep your model within 30 minutes of being runnable. So I'm going to run it. Here we go. And the population is being wired up, infection is spreading, and we'll let it spread. So people recover, it starts to spread again. People recover, or sorry, when I say recover, what I mean is, the waning of immunity and so on. So now we have some people who have been infected more than once and a growing number of times. Let's go over to this panel, the so-called developer panel, and let's go down to the population. Here's a population member. They're currently susceptible. They've been infected 0 times. That's this one down here. Let's up it. Here's a person who's recovered. They've been infected no fewer than 9 times. This one has been now 10. So they may be in that core area. Let's look. Oh man, their monthly income is really low. So they're in that core of the network. And you could see they're getting battered about by this infection again and again and again with their crowded conditions. Okay, so now we have a income for people, and we see that it puts them at risk of infection. The next thing we're going to do in the next little video here is we're going to look at the relationship, the association between income on the one hand and infection count on the other. So I'm just because it takes me a long time to label these videos, I have to watch the content some and so on. I'm just recording that.